mass moment of inertia. Is that clear? Okay. Now, with all these four properties, you will know how to deal with any kind of complicated objects. First, if they are not, use the property of symmetry to simplify the problem, or use property of equivalence to simplify the problem. These two are basically for your simplifying the problem. But the third property of superposition and understand the meaning of negative volume, these are the tools for you to actually calculate or dissect complicated objects into simple ones. So with all these four features, you will be able to solve all different kind of problems. All right? Now, let me give you one example, which is example 22. Example 22 is this. Now, let's consider a cylinder, which is shaped like this. And of course, the cylinder can be defined by its longitudinal axis. And the cylinder has a radius of capital R. The length is h, or the height. It's not the length, it should be called height. The height is h, radius is capital R. And we want to know what is the mass moment of inertia with respect to the z-axis, which is this one here, because we usually define this to be x, this to be y. We want to know that what is the mass moment of inertia with respect to the z-axis. Right here. That means we want to find out IZ. That's what we want to do. Now, the only thing interesting about this problem is, what if the mass density is not a constant? What if mass density is actually a function of radius? And this coefficient is k plus a nonlinear term that is a times r squared. Here, regular k and a, they are just coefficients. The point is, mass density is non-linearly dependent on radius, which is the axis right here. So how do we find out IZ? Now, to do that, first of all, we know that we have to define the unit volume. So unit volume is denoted as dm, right? That's the first thing, because whenever you want to calculate r squared times dm, you have to know how do we define dm. So in this case, how do you define the dm? If you look from the top, this is the z direction is perpendicular to this plane, right? We are looking from the top, and we know that the radius is capital R. If we use cylindrical coordinate system, this axis is what we call the r-axis, right? So this will be r-axis, because for cylindrical objects, it's not convenient to use Cartesian coordinate system. It's better to use cylindrical coordinate system. If this is r, that means any little change here in this direction is what we call dr, correct? dr is defined this way along the axis r. Correct? Right? If this is r, and this must be dr. Therefore, the first thing we have to figure out is how do we calculate the entire volume. The entire volume is defined by finding the perimeter of the circle and also at this little strip. This is how we calculate the strip. The thickness here is dr, right? So we are integrating this ring from what? From r to be 0 to r to be capital R. Because we're basically integrating from this point all the way to here. And every time we calculate the volume of this ring. So how do you find out the volume of this ring? Well, the volume of this ring is the perimeter times the thickness, right? So what's the perimeter of a ring or the perimeter of a circle? That's 2 pi r, right? So here you have density rho. Of course, we don't know what this one is actually here, so we'll worry about that later on. Times perimeter, 2 pi times r, and times dr. So here, this is the area of this ring. 2 pi r is perimeter, dr is the thickness. If you multiply 2 pi r by dr, you get the area. And we still need to have the thickness. In this case, the thickness is the height, which is h times h. This together is what we call dV. Now, if you multiply dV by rho, you get dm. Is that clear, Mike? Okay. So once we establish this, and you just plug everything into the equation. So here, we don't know the value of rho, but we know that rho is the coefficient, and that is k plus a times r squared times 2 pi r times h times dr. Now, remember, besides r, everything else, just treat them as constant. So you only have to focus on those, only focus on r. Everything else, they don't bother you. They are just constant. So we just have to figure out the terms depending on r, because the integral will be based on dr. Therefore, this thing can be written as, put them together, and you can move this one to outside, and then that means we're going to have 2 pi times h times this thing here. We're going to have k r plus a r cubed times dr, right? So step 2, what we do is just integrate it. And this integral, remember, is based on dr. So it's going to be from 0 to capital R. And then just put the expression here. 2 pi r, 2 pi h times k times r plus a r cubed dr. Remember, this constant. 2 pi h is constant, k is a constant, a is constant. The only thing you have to worry about is just r. So can we carry out this integral? Yes, because this is integral of polynomials, right? You can move the 2 pi h out of this integral, which gives you this. 2 pi h, they are constant. What about this for the first one? K is also a coefficient, so just treat it as a constant. You integrate r, you get 1/2 of r squared, right? So that's what we have. 1/2 r squared plus, what about this? A times r cubed becomes 1/4 of times A times R quadruple. And this integral is from 0 to R. Correct? Because A, K, 2 pi R, they are all constants. So this result turns out to be what? Well, actually, this is not IZ. This is actually what? This is M. I'm sorry. Because we integrate this entire volume. This is dm. dm is here. We integrate this. So this is dm. Correct? Sorry about the confusion before. And this result is pi times h times r squared times k plus a r squared over 2. So from here, we have the, and this is actually just the volume. I'm sorry, the total mass.
Professor, one question. If K is a constant, shouldn't be K over 2R squared plus A over 4?
You're right. Thank you very much. Because we still have a K here. You're right. So this is K. Good catch. Thank you. Yes, Liz, thank you.
Yep.
All right, so just remember, we integrate dm, so this is not ix, this is just m. So eventually we found the value of m right here. Okay, now I will finish this example on Friday. But now I think we take some time to practice this. Does it work?
Yeah, it works.
You can see.
I like this way better, actually, than the other way.
Okay. So if this approach works, I'm going to stick to this approach. What I'm going to do after class is to edit the video and post it onto the Blackboard Collaborate. So you will still go to Blackboard Collaborate to download the recordings for your reviewing. Okay, and I will see you on Friday. Okay.
Awesome. Thank you.
Thank you, Professor.
Sure.